Today we're going to look at EAS translations. And so I'm going to start with 2 points. This point is labeled point AB, and this point is point CD. Now for a translation, I'm going to move each point a fixed distance, which I'm calling distance d, in a fixed direction, which I'm calling theta, so it's theta degrees. So I'm going to start by finding the initial distance between point AB and point CD. And that initial distance is A minus C units down plus B minus D units over. So that's how I get this equation. So now I'm going to turn this into a triangle, and I'm going to label the distance that each point moves. So I'm going to label this capital R for my rise and lowercase r for my run. So this point AB and point CD are moving each to these new blue points. And as you can see by my blue arrows, this is how I figure out this equation. So now point AB is going to be point A plus R, as you can see, point A plus R because it moves over to here, and point B plus capital R because it moves up to here. So this point moves over R and up R, so that's how I get my new one. Same with point CD, it's C plus my run over, comma D plus my rise up, which is how I get these new blue points. Now what I'm going to try to find is the distance between my two new points, A plus R, B plus R, and C plus R, D plus capital R. And so as you can see, what I'm trying to find is, for this first part, I'm taking my A plus R and I'm going down to meet with my C plus R, and I'm doing the B plus R part, and I'm moving it over to see the D plus R part. So that's how I get this equation. A plus R minus C plus R, and B plus capital R minus D plus capital R. Then I just do a little bit of distributing, and I distribute my negative sign. So I now have A plus lowercase r minus C minus lowercase r, and then B plus capital R minus D minus capital R. Then you can see I can cancel my r's right out, so I get A minus C plus B minus D, and these are in brackets because I want the absolute value, because you can't have a negative distance. So this will work with any equation if I keep these brackets here. And then, as you can tell, the distance between my new points and my initial distance is exactly the same. So that shows me that an EAS translation is an isometry because it preserves the distance.